Welcome back. So now we'll see some manufacturing processes in action, both processes used now and processes that will be used more in the future. And let's start with a simple example, the Lego brick, arguably the world's most popular toy. The most distinctive feature of a Lego is that it's easy to assemble. It snaps together and comes apart, and you can buy Lego bricks in many different sizes and shapes and colors to build basically whatever you want. Lego bricks are made by a single process, plastic injection molding, that we'll discuss in more detail later. And if you walk into Lego's manufacturing plant, you see many injection molding machines that take the raw material, plastic and pellets, inject it into mold tooling, and produce the bricks one after another. In order to make the bricks snap together like you want to build your Lego set, Lego needs to understand the fundamentals of the process and maintain good quality over long periods of time. So yeah, Lego bricks are a simple piece, one process equaling the unit of the Lego product. But think if you're Lego and you want to bring out a new Lego set, for example, the model of Darth Vader that they just started selling along with the latest Star Wars movie. And unlike the simple rectangular bricks that we saw a moment ago, this set involves lots of different bricks with complex shapes. And like the rectangular bricks, they have to fit together nicely so you can articulate Darth Vader's arm to move his lightsaber, and you can assemble the set easily and conveniently. And for each of those bricks, even though the process is the same, Lego has to have the best understanding of the fundamentals of the injection molding process. Now, from simple to complex, at the other end of the spectrum, we see electronic devices. Amazon now sells a $50 tablet computer that has a touchscreen, Wi-Fi, battery, speaker, pretty good processor and memory. In order to make this, to achieve the value at scale that lets them sell it for $50, they have to manage a supply chain and they have to integrate so many different process technologies. And as we go through the semester and you study more advanced processes in the future, you'll appreciate the intricacy involved in manufacturing each individual component. Even the coatings on the glass or a single material in the battery or on the circuit board involve its own manufacturing process, an analogy to the Lego brick. And as electronics become more cost-effective, less expensive, and more ubiquitous, we're also seeing the integration of electronics in consumer products, what I might call smart products. So a couple examples. This is a new product from a startup company in California called Roost, and it's a smart battery. So if you want your smoke detector to alert you via your smartphone when it goes off, you can buy this battery, and this battery functions as a battery for the smoke detector, and it also has a piece of electronics in it so it can send an alert to your phone when the alarm goes off. And also on Amazon, you can purchase what they call dash buttons. And these are buttons that will connect to your Wi-Fi network and to your Amazon account. And for example, you can mount one on your washing machine. And seriously, if you run out of laundry detergent, you press the button and Amazon will order laundry detergent for you and it'll come to your house in a couple of days. Now, you might think that's a little bit extreme, but the fact that they can make these buttons or these smart batteries shows that electronics are integrated in many design and manufacturing operations these days. And I have a couple examples here as well. This is the Roost Smart Battery, and I took the cover off the bottom, and it's got a normal size 9-volt battery, but at the bottom you see the electronics that allow it to be smart, to allow it to communicate. And over here I have a couple of the dash buttons, and I kind of think of this dash button as like a smart Lego. You don't build it together, but it's about the same size, and if I open it up, I take away the injection molded plastic components, I see a circuit board. And the circuit board has almost infinitely small things on it, circuit components and resistors and processor and communication devices. And you can imagine the many, many years of advances in electronics manufacturing technology necessary to make this cost-effective to manufacture. And you see a conventional battery underneath as well as the plastic housing and one of the screws that holds it together. So, when we think of manufacturing, we should not only think of, how all this stuff is made, but how it gets to us. And so if I have one of these automatic ordering buttons, I press it because I've run out of shaving cream, and Amazon dispatches an order to me to arrive in 2 days. Well, what might happen? Well, they have to pull the product from their warehouse. And this is a video from one of Amazon's warehouses using a robotic warehouse technology invented by Kiva Systems, which is now now Amazon Robotics because Amazon acquired it. And as you can see, automation in making warehouse operations more efficient, bringing the product to the person that packs your order into a box so it gets sent off and shipped to you, is also an advance in manufacturing, in improving the efficiency of getting the product to your door. And that's not only making the product, but that's packing the product and shipping it to you. And advances in robotics and automation are going to play a huge role in the future of manufacturing. Now, extending the example of the automated warehouse we saw a moment ago, one of the things Amazon is working on now is developing robotic technology to pick products off the robotic shelves and put them in the boxes that are shipped to you. Now, it's an interesting and complex issue, what happens if the robot replaces the human that packs the boxes? But that aside, this is really interesting technology and difficult to achieve. Because when you think of the wide variety of things that Amazon sells, from big boxes of Legos to small tablets like the $50 tablet we described before, to things like food, cookies that are fragile and delicate to handle, it's hard for a robot to pick up something oriented and put it in a box. And if you're someone like Cookie Monster that wants to have good quality cookies delivered when you press your button, you don't want the cookies to be damaged when they come to your door. Now, another thing I'm really excited about is 3D printing, aka additive manufacturing. And we'll spend some time on this later, but across industry, we're excited about 3D printing for pretty much every material and many different applications, from jet engine parts to shoes to enhanced performance tooling for making injection molding, like Lego making more cost-effective and faster, to things like personalized medical devices, where you can make a custom stent and implant it in someone's chest, perhaps to save their life. To new models for product design, Google is advancing the idea of a modular smartphone where different designers and small manufacturers could create different modules that consumers could then buy and mix and match in their smartphone rather than upgrading the whole phone at the same time. Coming back to my definition of manufacturing as value at scale, I think we can now appreciate that in order to achieve that, for each product you need to put together often multiple processes, and it's not only the processes of making the parts, but it's extracting the material, and it's taking those parts and packaging them and shipping them that create the final point of value and define the scale at which the product must be manufactured. When we think about new things in manufacturing, robotics, high-end automation, 3D printing, and advanced materials, we're going to use those to continue to push value at scale, and we're also going to perhaps expand this space a little bit. Each product might have a different definition or a different position. For example, fewer hip implants and more water or more potato chips. But also, say, 3D printing has the concept of being able to produce a small volume of complex parts without having to invest in tooling. And that can let us think about new business models in manufacturing, and also the effect of automation on localization of manufacturing, making things here rather than there, and how that influences certain aspects of manufacturing as a business and as a capability. And those things involve a lot of high technology, electronics, automation, etc., but also the simple things are advancing. And by the simple things, this is a great example. So I saw an article in the newspaper recently that said that Lego is investing a lot of resources and time to discover a polymer, a plastic that can replace the plastics used in Lego bricks. And why would they want to do that? Well, because even though Lego bricks work really well, they're using petroleum-derived plastics that come from the earth and have a certain environmental footprint. And even though Lego says it'll take 15 years and a lot of science as well as development, they're committed to developing an alternative that must, of course, make the Lego bricks still work and look as good as they do now. So we'll see a lot of these advances, and I hope that through our journey you'll be thinking not only about the present, but also about the future.